In order to solve this problem, the first thing we need to establish is the Langrangian relationship, because the question actually stated it clearly that you should write out the Langrangian equation of motion of a particle in spherical coordinate. Since we know that our L is equal to T minus V of R, where our V of R is the potential, and T is the kinetic energy, which is equal to half mv squared. Please, let's note there's a difference between this V and this particular V. This one is with respect to R, while this one is the speed, the velocity. But for a spherical coordinate, our V squared is the same thing as R dot squared, R dot squared plus R squared theta dot plus R squared sine squared theta phi dot squared. So we are going to introduce this into this particular expression. So, and after introducing it here, we are going to introduce them into the Langrangian expression. So our Langrangian expression L is equal to half m into bracket R dot squared plus R squared theta dot plus R squared sine squared theta phi dot squared minus V of R. From this particular expression, since R is a spatial variable which may really contain x, y, z, it means the expression actually depends explicitly on x. So what we are going to use is partial of L, partial of R, since I have actually represented everything by R, minus d dt into bracket partial of L by partial of R dot is equal to 0, which means that our partial of L by partial of R is equal to d dt into bracket partial of L partial of R dot. So let's label this as our equation 1. So from here, what is our partial of L by partial of R? Our partial of L by partial of R, we were told that the potential is a constant, which means that if we differentiate it with respect to R, it will give us 0. So automatically what we are going to differentiate is this one. This one actually contains R, this one contains R, but this one contains R dot. So automatically we are going to have 1 over 2m into bracket 2r theta dot plus 2r sine squared theta phi dot squared. So this one is going to definitely give us mr theta dot plus r sine squared theta phi dot squared. That is the expression for partial of L by partial of R. What about partial of L by partial of R dot? The only one that contains R dot is this one. So automatically what we are going to have is 1 over 2 m into bracket 2 this. So this one is going to give us mr dot. What about d dt into bracket partial of this by partial of R dot, which is equal to mr dot dot. Are we together? Since our partial of L by partial of R is equal to d dt partial of L partial of R dot, so automatically our mr dot dot will be the same thing as mr theta dot plus r sine squared theta phi dot squared. From this expression, since we are done, from this particular expression, this one actually represents the force, while this one represents the centrifugal force, this particular expression. So from here, but what is our r dot dot? It means we are going to divide all through by m. There should be m here because this m actually covers everything. So there should be m here. This m covers everything. So automatically we are going to have this one to be equal to r this dot plus r sine squared theta phi dot squared. So that is our final expression. So let's call this one number 2. So the next thing, what other variable is present in this particular equation? We have theta, and we have theta dot and we have theta. So we are going to solve with respect to theta also. Partial theta is equal to d dt into bracket partial L by partial theta dot. So what is partial L by partial theta? Partial L by partial theta. This one contains theta. So if you want to differentiate this one does not contain theta. This one contains theta dot. So if you want to differentiate this, we are going to have 1 over 2m into bracket 2r squared sine theta cos theta phi dot squared. So automatically this one will give us mr squared sine theta cos theta phi dot squared. So the next thing is for us to solve for the theta dot. So we are going to have partial n by partial theta dot. So we are going to have this as 1 over m, 1 over 2 m into bracket 2r squared theta dot. So what is the thing of this particular expression, partial L by theta dot? So this one is going to be d dt of mr squared theta dot, which is the same thing as, since you know that r is a function of time and theta dot is another function of time, so what we are going to have will just be equal to 2mr theta dot, that is, we kept theta dot and m constant, we differentiated r. But if we keep m and r constant and we differentiate this, we are going to have mr squared theta dot dot. So automatically, if we reintroduce everything back into this particular expression, so we are going to have this to be equal to partial L by partial theta is equal to d dt into partial of L partial of theta dot. So what is this? This one is the same thing as this. We have 2mr theta dot plus mr squared theta dot dot is equal to this particular expression, which is equal to mr squared sine theta cos theta phi dot squared. So we can divide through by m. So we are going to have 2r theta dot plus r squared theta dot dot is equal to r squared sine theta cos theta phi dot squared. So we can also divide by r squared. So we are going to have this one to be equal to 2 theta dot against r plus theta dot dot is equal to sine theta cos theta phi dot squared. That is, if we divide all through by r squared. So automatically, what will be our theta dot dot, which is equal to sine theta cos theta phi dot squared minus 2 theta dot against r. So that's our final expression for theta and theta dot. Hope it is clear, man. If that is clear, this is our Coriolis. This is our Coriolis. So the last one, since we still have phi as part of the variables which v depends upon, so automatically we have to also solve for phi dot and phi. So the next thing is to say our partial of n by partial of phi is equal to d dt into bracket partial of n by partial of phi dot. So what is partial of n by partial of phi? Since explicitly it does not depend on phi, so automatically this one is what? 0, because there's no expression for phi. So what about phi dot? Partial of n by partial of phi dot. This one will eventually give us 1/2 m into bracket 2 r squared sine square theta phi dot. So from here we can easily cancel the 2. So we are going to have m r squared sine squared theta phi dot. So what about d dt of this particular expression phi dot? It will be equal to d dt into bracket m r squared sine squared theta phi dot. So by the time we introduce this into this particular expression, so what we are going to have is partial of n by partial of phi is equal to d dt into bracket partial of n partial of phi dot. So this one is just the same as d dt into bracket mr squared sine squared theta phi dot is equal to 0. By the time the derivative of a function is equal to 0, it means that particular derivative is what? It's just a constant. If you differentiate something and it gives you 0, it means it is a constant. So once it is a constant, automatically our mr squared sine squared theta phi dot is just equal to a constant. Let's call it k. So what is our phi dot? Our phi dot is just the same as k over mr squared sine squared theta. Thank you so much for listening. Please subscribe to our channel. Thank you.